Hey folks, this video is going to work you through the remediation for target 11, which is solving systems of linear equations. All right, this target's kind of heavy, it's loaded. There's several things in it that I'm going to show you we're going to work through. We'll go from there. So let's get started. All right, first problem I'm being asked to do is solve this system of equations by using substitution. Okay, so first of all I want to talk about solving, or a solution. What does a solution even look like? All right, well, what we're looking for is the value of y and the value of x that work in both of these equations. Okay, so my solution is going to look like this. It's going to be a point, and it's going to be an x value and a y value. That's how I'm going to list this. All right, and that x value and that y value should be plugged in to each of these equations, and they would work. Okay. All right, so I'll show you that when we check our solution later, but let me show you what this substitution thing is all about. All right, with substitution, what we really need is we need one of the variables to be by itself. All right, so we either need y by itself, so y equals something, or x equals something. All right, so in this case, we actually have both equations where y equals something. All right, so what I'm going to do is I'm going to grab a pen, and then, all right, what I'm going to do is I'm going to take this equation, or this part of the equation, and I'm going to substitute it in. I'm going to take this expression right here, and since y equals that, I'm going to put this over here on that first equation. All right? That's how I'm going to do it, okay? So I'm going to write this first equation, but instead of y, I'm going to put this. All right, so I really don't need my parentheses in this case, so I'm just going to write negative x plus 5 equals, okay, that was y, I just put it there, and that equals x minus 3. Okay, what I've done is I've substituted this in, and I've created an equation that only has x's in it, so I can solve for it. Okay, so I'm going to add x to each side. And I get 5 equals 2x minus 3. I'm going to add 3 to each side. Oops. And I'm going to get 8 equals 2x. I'm going to divide by 2. And x is going to be 4. Okay. So here's what I know. I know that my x value is 4. All right? It has to be. Right, because of this process that I went through there. Now, I still don't know what the y value is. So what I need to do is I need to take this x value of 4 and put it in one of these equations and then figure out what y would be. Well, right here is a really easy place to put it in, right? If I replace x with 4 here, 4 minus 3 is just 1. So y must equal 1. Okay. Well, let me check this down here too. What if I put it here? If I take 4 and I plug it in here, negative 4 plus 5 would also be 1. So y would equal 1. Good. That's what I need to have happen. This is the x and the y that I can plug into both of these equations, and it would work in both places. All right. Problem number 2, I need to use substitution as well. All right. This one's a little different though, a little more complex, because although I have an equation that is just solved for y, or has y by itself, this one's a little bit uglier, all right? But I'm still going to substitute, because right here there's a y. So wherever I see y in this equation, I'm going to put in this instead, this expression. Okay, so let's see how that works. So here we go, x plus 4, not y, I'm substituting this expression in there. And I am going to put parentheses on this one because this problem is going to require me to distribute. I'll show you that in a second. All right, so there we go. I substituted. And equals negative 2. All right, now I have an equation with just x's. Right? My first step is I do need to distribute. If you recall, distributing is multiplying this number here, in this case, positive 4, multiplying that by everything Okay, we're distributing that, multiplying to everything in the parentheses. Okay, so 4 times 2x is 8x, and then minus, and 4 times 5 is 20. Okay, and then I still have all this stuff. Equals -2, and I can keep going. Oh, well, this, I can just put this together, right, because it's on the same side of the equal sign, so I just combine it. Minus 20 equals -2. I'm going to add 20 to each side. And I get 9x equals 18, and then I'm going to divide by 9. And my x value is 2. So x equals 2. All right, so I need a point. My solution needs to be a point. It needs to be an x and a y value. All right, so I know in this case my x value is 2. All right, I'm going to take that and I'm going to plug it back in here. All right, so let me erase some of this stuff so we get it out of the way here. Okay. All right, so if x is 2, I would put a 2 right here. So 2 times 2 minus 5. Okay, that's 4 minus 5 is -1. So my y should be -1. All right, I'm just going to kind of mentally do that here. Let's see, x is 2. 4 times -1 would be -4. 2 plus -4 is equal to -2. So I just confirmed that that is indeed the solution. Okay? All right, problem number 3, we're going to use a different method. Same goal, right? Same goal. We need to find an x and a y that fit in each of these equations, right? We're just going to use a different method. This one's called elimination. And here's why. Because when we combine equations together, when we kind of think of adding them together, which we can do, because this is equal to this, and this is equal to this. So if I add this side of the equation together, and then I set that equal to this side of the equation, added together, it should still be true, right? So that's what I do, and we have to combine our like terms, okay? Think of that. So I'm going to add my x's, I'm going to add my y's, and then I have to add the other side as well. Okay. So here's the beauty of elimination. If you have opposite coefficients, as I do here, right? I'm going to get my circles out of the way. As I do here, I have a -5 and a +5. When I add those together, they're going to just cancel out. So they're being eliminated. Okay. So here, 5x plus 2x is 7x. So I do combine that still. And then 20 plus 15 is 35. So I do have to combine that as well. And look at this. This is really easy to find my x value now. I just divide both sides by 7, and my x value is 5. All right. So we did that by eliminating one of the variables. Right? We eliminated the y's by combining these two equations. Okay. All right. So now, similar to before, I need to take this x value and I need to plug it into one of these equations and solve it. All right, I'm going to grab a different color here. I'm going to use this one right here, this equation. Okay, just because it's got a little bit smaller numbers. Okay, so here we go. 2x, so 2, but I know my x value is 5. So 2 times 5. Okay, now I continue. Plus 5y equals 15. All right, well, this is 10 plus 5y equals 15. I'm going to subtract 10 from each side. So 5, whoop, go back. There we go. 5y equals 5, and y equals 1. There we go. All right, so my solution here is 5, 1. And again, you could plug these into the other equation, make sure they work, okay? All right, now we'll go on to this one. Erase that little there. Okay, similar idea. I want to use elimination, all right? And I'm going to combine my x's, I'm going to combine my y's, and I'm going to combine the other side of the equations. Okay, the little bit added task here is that right now, if I combine, nothing gets eliminated. Right? And I need that to happen. so we have an extra step here. What I'm going to do is I'm going to take this equation and I'm going to multiply every term by something, okay? And I'm going to do it in a way that allows me to cancel either the y's or the x's, all right? In this case, I'll show you. I'm going to multiply everything in here by 6, all right? Why am I doing that? Because when I multiply the 6 times the y, I'm going to get a 6y. And negative 6y plus 6y is just 0y, or it goes away, right? So here's how it works. 6 times x is 6x. 6 times y is 6y. And then 6 times 10 is 60. 60. There we go. All right, now when I combine these, and I'll bring this down just so we can see them right next to each other. When I combine these, we're going to get an elimination. All right, right there. Let me change color here. That gets eliminated. All right, so when I combine these, I get 8x. And add this, that's 72. All right, divide by 8. And x equals 9. All right, so I found one of the variables, in this case, x, once again, first. Okay? So, I got to use this and plug it back in here to one of my original equations to find my y value. This one right here is really easy, isn't it? Right? X plus y equals 10. Well, if x is 9, then y would have to be 1. Right? Piece of cake, right? To be safe, I should plug those back into this equation and test it out as well, just to make sure, because it should work in both. Okay? All right, that's elimination. We have one more method. All right, we can do this by graphing. We can solve a system by graphing. All right, what we do is we graph each of the equations as a line on the same graph. And what they're going to do is they're going to intersect, or most of the time they'll intersect. And wherever that intersection is, that is the solution. Okay? All right, so let's just do it. I'll show you how this kind of works. All right, so here's -1 is my y-intercept right there. And then my slope is 1/2, or 1/2. So I'm going to go up 1/2, up 1/2. It's a good idea to do several points so that you get your lines graphed pretty accurately, right? If you have any errors in the graphing, you could likely have an error in the solution as well, okay? All right, so those are those points. And let me grab a line here and put that in there. I want to make sure it's green just because I want it to match. And I'm going to do like that. That bothers me a little bit, so I'm going to move this up a little bit, and there we go. Okay. All right, I'm going to graph the other one. This is our first line, and these are all the solutions to that first equation. All right, all these xy points on the entire line. This one I'm going to use blue. I have an intercept of 5. 1, 2, 3, 4, 5. Y-intercept. And then my slope, well, -x, that means that it's like -1x, right? So -1x, so my slope is -1. Down 1/1, down 1/1, down 1/1. I can see this is where I'm going to intersect, right? Right there. And I'll do a couple past. Okay, so I don't have to go any farther because I know my intersection is this point right here. I'm still going to draw that line in. Okay, so let's do that. And this will be good. Oh, that's green. Sorry. I'm going to leave it green because I don't want to waste your time. But I am going to extend it a little bit. Actually, no, I'm not. I'm going to change the color quick just because I can super fast. There we go. All right. So there we go. We graphed both the lines and we found the intersection point. Right? That's what we were looking for because these are all the solutions to the green. These are all the solutions to the blue. When we overlap them, we get a solution that works with both of them. right? And that is our goal. So once again, our solution is a point, and in this case, it is 4, 1. 4, 1. Okay? Explain the meaning of my solution. Well, I just kind of did, right? This is the point that is shared on both of the lines or works in both of the equations. Okay? That would be the meaning of the solution for our system. Right? That's how we find it by graphing. All right, final thing. We have an application. Right? We can build these systems and then we can solve them. Right? So here's one of our scenarios. Brenda and Devin each updated the landscaping around their homes by planting hostas and ivy. They also bought the plants from the same store. All right. Brenda spent $85 on 7 pots of ivy, 12 hostas. Devin spent $60 on 6 pots of ivy and 6 hostas. I want to find the cost of 1 hosta plant and the cost of 1 pot of ivy. Okay, so these are the things I'm looking for. Cost of 1 hosta plant, all right? And I'm going to define some variables here. So that's my x. My x variable is going to be cost of a hosta plant, all right? And then my y value, I'm going to define a variable y, and I'm going to let that represent my cost of 1 pot of ivy. Now, you don't have to use x and y. You can use any variable. You could do h and p if you wanted to. I'm just going to use x and y, okay? Those are my 2 defined variables. Now I'm going to write a system using those. Okay, so let's look at Brenda's. Here's Brenda. Okay, she spent $85 on 7 pots of ivy and 12 hostas. Okay, 7 pots of ivy was y. I'm going to do a little color in here. 7 pots of ivy. Okay, so I'm going to do 7y. Okay, and 12 hostas. I missed there a little bit. 12 hostas. That was x, right? Okay, so plus 12x. All right, that equals a total of $85. Okay. All right, now what about Devin? Here's Devin. And we're going to write a system for what he did, right? So Devin spent $60 on 6 pots of ivy. So pot of ivy, I'm using green. There's 6 of those, right? So my pots of ivy are y, right? So I'm going to do 6y. And then 6 hostas as well. Okay. So my hosta plants were x. I have 6 of those as well. So plus 6x. Right. And that cost him $60. Equals 60. There we go. So what I've done is I've created a system that I can solve. I have 2 equations, 2 things I know, and I have 2 variables. I can figure them out. All right. So this one looks like it's pretty well set up for elimination. All right. However, I'm going to have to change one of the equations because I don't have opposite coefficients yet. And this one's close, though. If I multiply, I can see this term by a -2. That's all I'll need, and I'll cancel that there. Okay, so that's what I'm going to do. I'm going to multiply all these terms by -2. All right. So this is going to be -12y. This is going to be minus 12x. And that's equal to, this is going to be -120. Okay. Now when I combine, right, 7y minus 12y is -5y. 12x minus 12x is gone, equals, and then 85 minus 120 is -35, right? Divide both sides by -5, and that's going to give me y equals 7. Okay, y equals 7. All right, so I got that going for me so far. Now I need to find my x value, right? So we have to use one of these equations. I'll use this one. It's a little smaller. Okay. So I'm going to do 6y, but I know y is 7. Right? Let's do that up here. 6 times 7, 6y, 6 times 7, plus 6x equals 60. All right, this is 42. I'm going to subtract that 42 from both sides. So I'm simply solving here. I get 6x equals, that's going to be 18. And divide by 6. And x equals 3. Sorry about that. I got to move that. X equals 3. Okay. All right. Now, I'm not entirely done with this because what I wanted to do is find the cost of a hosta plant and the cost of a pot of ivy. Okay. So really what I should do somewhere is I should answer those two things. All right. I'm not going to write this in here because I don't think I left myself space, but you should. Okay. So what I'm going to do is I'm going to write the cost of one hosta plant is my X, $3, or it costs $3 for one hosta, something like that. And then similarly for a pot of ivy, it is $7 because that was my Y variable. Okay, so $7 for a pot of ivy. Those are the two things that we need to write here. All right, that's answering the question. Okay, but it's using this process of building a system and solving it using one of our three methods, either substitution, elimination, or graphing. All right, there you go. There is target 11.